Hello everyone, it's Krish back again with one other episode. So, thank you very much for comments, feedback, also Twitter messages, question ask. And if you're not subscribed yet, go ahead and subscribe right now because there are so many important things to come. There are so many things us to learn together. So go ahead and subscribe right now. And also share this video if you have a community which you think this type of video would be interested. Some people ask how they can support for this channel, and thank you very much for your idea and your encouragement and your enthusiasm. And I haven't decided yet how I can do that. There are so many requests came. Can we move this content to Udemy or some platform so you can get some benefit of this? Yeah, I understand, and thank you very much for your ideas. And but still I'm going to make this channel freely available for everyone. Not this content, all the content I've been creating for this channel. But I'll figure out a way how we can interact, and how, if you want to support, how you can support for the channel. I'll figure it out and let you know. So far we have discussed some basic principles and some concepts, and also all the aspects of the security. Now it's a time to sail this ship into deeper sea, which means from today onwards we are going to learn some advanced concept. That means we are going to put some advanced principles concept into our project and make this project real industry standard level project. End of the day, you will have the project which has every aspect of the microservices. And also there are a lot of people asking how many episodes to complete this course, and what we are going to cover. And to be honest, I cannot give a straightforward answer to say how many episodes we have, but I can tell you, if you follow this course, you will have everything what you should know about microservices. For example, today we are going to talk about asynchronous services or a task, serverless computing, and then we are going to move into load balancing, service discovery, API gateways, and also exception handling. Not only that, message brokers, distributed tracing, and finally we are going to deploy this along with the Dockers or some other containers into the cloud. And also I am going to cover how you can put all this together and build single service stack for your needs. That means we are going to learn everything. So forgive me, I have no idea how many episodes I'm going to create, but from this video I'm trying to make at least 2 videos per week because there are a lot to cover. For example, I'm expecting to cover resilience using circuit breakers and those type of state-of-art technologies and design patterns and stuff. So that being said, let's jump into the content today. Today I'm going to talk about asynchronous behaviors for the services. Why we really need this? Because we had SOAP services, but in year 2000, Roy written his dissertation about the REST services, so we moved from SOAP into REST. Now the REST is mean to asynchronous, but most of us use HTTP as a protocol or communication protocol for REST services. But we all know HTTP is a synchronous protocol. It is not a synchronous protocol. Up to HTTP 1.1, it's a synchronous protocol. So if you are building your REST services on top of a synchronous protocol, then you cannot expect asynchronous behaviors from your REST services. I mean, a real asynchronous behaviors from REST services. To avoid this type of confliction, we can use messaging platform. If you are using Java based, JMS, or any other messaging framework, to avoid this conflict in between asynchronous architecture on a synchronous protocol. For example, you can publish your content into message broker, and other end someone may be listening to message broker. In that case, you can get the real asynchronous behavior. So I'm going to show you how we can do this with a Spring application, a Spring Boot, and along with the Spring task. First, let's see why we really need this. For example, if you have, let's say you have some system, you're implementing some service stack. That service stack has some small function to do. For example, let's say when you submit some certain recorders, it's supposed to generate invoice, send some emails, and adding some loyalty points and some stuff, right? So now we all move into user experience, build the user experiences. Let's say you click the submit button. If the user has to wait for 5 seconds or 10 seconds or 15 seconds, then it's not a pleasant experience for the user, right? And also it may be user is hesitate to come into your application anymore, because user experience is the biggest challenge this generation. So it's better if you, when user click the submit button, if he can give the feedback to user, and if he can do this task asynchronously without keep user waiting, that's be really fantastic approach. So to do something like this, we can use something like a sprint task. So what it does is, you do your task and you kick off a task, and task will go ahead and do the job. First we'll see why we need this type of thing. So we make to make asynchronous processes, so can reduce dependencies between services. For example, as I said, your invoice submission service do not need to wait until the email service send the email, or SMS service send the SMS, because your submission service, your invoice submission service, that can do its job and go back, right? So it does not need to wait until some other service complete their work. So reduce the blocking calls, right? This is what exactly this means, right? The blocking calls mean, so you generate the invoice, you have to wait until email service send the email and get the handle back to you and do your next job, then you have to wait other service complete their job. So you can avoid the blocking calls that lead to increase the throughput. So you can use also event driven model. For example, when some event happens only, you need to react. Get back to the same example, when the invoice submission event happens, you can go into your work, which is the generating email event. You can go with the event driven approach, and also you can avoid the cascade failures. For example, go back to the same scenario. You create invoice and now you are waiting until the email service send the email. Let's say some problem with the email server is slow, so it takes a lot of time to send the email, right? So now you are waiting, your invoice generation service waiting until email service doing its job, right? So now you cannot go back. Why? Because that guy is not completed his work, so you are waiting. So your waiting mean person who call your service is waiting. That means if someone else call that service is waiting. That means end user is waiting. So you can see when something happen in a one failure in one service, it is cascading all the down the line. So we call cascade failures. You can avoid that because your email service is an asynchronous one. You don't have to wait. You don't have to wait your other services until that service completed its job. Another important thing is sometimes certain services we don't use frequently. For example, we have a service which check whether any anomalies on the driving license number, right? When we have a services whether is there any record expired by today, right? We may have a services which may generate certain events, certain invoices by end of the day, right? So that means this service only has to work on the end of the day because to generate some invoices which is expired by today. So to do something like that, it is no point of wasting resource and running this resource forever, right? So what we can do is we can get this task, get this service run whenever it need, right? So whatever the content you are seeing here is all going to add to the same microservice slide, and this slide will be available on my SlideShare account. I'll put the link below, right? And so you can get this content as a PDF slide. And also we can solve the problem by without coupling it, loosely coupled, without coupling to the end service. We can solve the problems, and this lead to introduce to concept called serverless computing. Serverless computing is nothing but, so now what we have is, let's say we have our rent profile service or the customer service, right? So with this customer service, we can create customers, delete customers, update customers, do all those things, and also maybe probably add the loyalty points to the customer. So what the serverless computing mean, instead of deploying application services, that means do multiple functions, we deploy functions, we deploy as a function level, right? Remember in the, I think first or second video we discussed about functional decomposition, right? So serverless computing, if you take AWS Lambda, they do the same job. So what we are going to also do here with the task to implement a function and deploy that function separately, right? So it is not hard to do, so let's try to do one in practical, right? So let's go back to our IDE and let's create one service. So this is again similar Spring application. So Spring initializer. So I'm go back and give my package lk dot. So since this is not a service, I'm going to name this as a task. You go back and add the task dependency. That enough for now, you don't need anything else. Okay, so we got our service created. So you can see here now we have one class which is this one. So what you need to do is, and you need to go back here and add enable task annotation, right? So enable task annotation, this make this is a task service, right? So then we can have separate package for services, right? And we can have, let's say, rent process service IMPL, okay? And then we have, let's say, for example, now for now I'm going to just do the validation, right? See, we just, I mean, this is just a sample. So we are going to check whether driving license has more than 5 characters. This is just very examples. So don't worry about the real use case of this. I'm going to show that later, right? So that's it. So we created our service, and let's make this as annotate with the service annotation. So Spring can work with that. And so now I'm going to create a separate class, let's say run process task runner, right? So this is the one who's going to handle this. So this I'm going to implement this with command line runner. So I'm going to take this as a command line application. So then I have to implement one method, which is run method. So this is very equal to your main method. So you take string arguments and you take this. Let's assume I'm getting the driving license numbers as an argument. So what I'm going to do is I can annotate my rent process service IMPL. Ideally this has to go with let's do something right. So why we have to do this? So what I'm going to do is I'm going to extract interface from here. Okay, I extracted interface, and so now this is implement from rent process service. So here what I'm going to do is I'm going to annotate this with rent process service, and I'm going to auto wire this. All right. So here what I'm going to do this, if so I'm going to pass argument 0 here, okay. Okay, so that's all what I'm going to do is, but I need to make sure whether this has any arguments. If Okay, so this is a very simple logic. What we do here, we check whether it has argument. If there is an argument, we print task running with the arguments, and we take the first argument and send it to this our service, right? And if it is valid, it will print is a valid driving license number. If not, it will print it's an invalid driving license number. In the real use case, probably we may need to save into the database or do something else in the email or whatever. But here I'm just going to explain to show you how the task works, right? So you have two options here. Either you can make this as a service. In that case, Spring can automatically use it, or else what you can do here, you can create a bean from here like this. So you can say run service, run process task runner, okay, and you can make this as a bean, right? So if you add the component annotation or service annotation on top into the service runner class, that's also going to work. But I do this to show you how you can what are the other ways you can create a beans, right? Otherwise it's going to work without any reason. So I made a mistake. This is not to add here. It is very clear if you add this here, right? So without adding over there, it's very clear if you add this here, right? So this is my main class, and which is enabled, we add the enable task, and we have a service implementation. It just has one method, and the runner implement from the command line runner, right? And now we done what we want to do, right? So now I can run this task without any problem. So I'm going to run this to show you how this works, right? So you can see here task running without argument, right? That means our task is executed. So task executed, did its job and dead itself, right? So now what I'm going to do is I'm going to do something different here. I'm going to pass some arguments to here. So for that I'm going to build this. Okay, so now I'm going to run this jar file manually. Okay, and this time I'm just running this without passing anything. So it run without arguments. So now this time I'm going to run something like some arguments, right? So now it will take that argument, say task running with arguments, and it says valid driving license, right? So now again I'm going to run this with some invalid argument. So now it will say is a invalid driving license, right? So now we understand we did very simple thing, right? We create a task. So now how this task works, anyone can invoke this task. This can be from other service, this can be from cron job, this can be any way you want to do, maybe scheduled one. Somehow this task get execute. Once the task execute, it do its job and it die itself, right? It doesn't live anymore. The whole purpose of living this task is do one job, it do that job and it die itself. So now we have a problem. Let's say something like this. So you create this task to when someone submit the invoice, this task supposed to come back online and generate invoices, do the updates necessary, do update, probably stock updates and so many things. If you not familiar with the CQRS design pattern, command query responsibility segregation, so you would understand what I'm talking about here. If not, you can just recap, you can go and read about it. For example, let's say you submit an invoice, task comes, handle all the stock items and other tables to be updated, generate invoice, sending emails, and going to die itself. But the problem here, this task, it has a momentary life, right? It may have a few seconds, maybe 5 seconds, maybe 2 seconds, we don't know, maybe 10-15 seconds. How we can debug this task, how we can get to know whether this task is really executed, right? How we know this task failed, this task executed 5 times, how many times fails? There is no way we can track that because this guy is not living, right? So this guy comes, do the job and dying. So there is no way you can monitor or get an idea about the task. So what we can do is we can ask Spring to record the events whatever happened into somewhere. You can use either database you want, like it can be Oracle, it can be MySQL, it can be any other storage, whatever you can point, you can configure where to store, then it will save those information into the database, right? So you can go and monitor in the database. Let me to show how to do that. So I'm going to choose MySQL, right? So I'm going to choose MySQL to save this information. So what I'm going to do is here, I'm going to configure my database, right? So you remember we use YAML instead of property file, right? I'm just copy and paste to save the time. We don't need to go step by step anymore. So I'm copying and paste from my profile service all the database configurations, right? So these are the database configurations what we did. So here we need to, since we need to database to access, so we need to add the connectors, relevant connectors for that. So I'm going to add the MySQL for this. I'm going to add two dependencies here, right? So one is for Spring Data JPA to kick off my database, and also my MySQL connector for Java, right? So let me to re-import these dependencies. Okay, so now if you go back here, you don't have any errors. Keep in mind I use here taskdb, right? So I don't have taskdb in my database right now, and I use create database if not X is closed, right? If you are not using this clause, you need to make sure you have to create the database manually, right? So now everything is ready. So now let's run this one and see what happened here. Okay, so it says running without arguments. Now if you go back to database, you can see here the new database being created, right? And also it has all those tables. If you go here, you have task execution, and if you go here, you have task parents, right? So you have all those information here about the task. Let's say like we did last time, right? So let's go ahead and execute this task with some command. Okay, first I'm going to build this. Okay, so now I'm going to run this. With some numbers, right? So with some, let's say, driving license number. Okay, so task executed, and it says valid driving license, and it's dead itself, right? So let's go back and see what happened to my table. So it says now I executed this task in 3 times, right? And if I go here, now this time it says numbers, right? So this is the parameter. Execution ID is 3. This is the parameter I use, right? And if I execute again with some wrong parameters, I mean parameters which says wrong driving license number, so you will see that also in the database, right? So if you go back here, execution is 4, the parameter is this. And if you go back here, you have 4th execution. It says what time it been executed, exit code is what, and start time, end time. You have all those useful information hands on where you can decide what happened to the task, right? So if you summarize, we need to achieve asynchronous behavior, which means the non-blocking calls. The one service should not wait until other service complete its job. We can achieve this easily using tasks. So how this task works is, task comes up, right? Someone has to kick it off, like probably when from other service, probably a cron job, probably scheduler, doesn't matter how. If you get our example, right? So there is an invoice submission. After submit this invoice, that there is a task being invoked by this invoice submission service. This task will go back and update the necessary tables and generate the emails and the invoices and everything, and die itself. Born its own, do the work, and die its own, right? So that is the beauty of the task. So now how this is, what is the advantage of this? Let's say now server, usually there are 10 invoices being created on every seconds, 10 TPS, right? So now your user will experience, let's say 500 millisecond response time. When user click on the submit button, there are 10 other invoices being created, but still you get the 500 millisecond response time, because you just need to submit it. So let's say for some reason, for certain day you get 1000 TPS requirement, right? So now you scale your invoice submission service. You don't have to worry about the task or email services, right? Because this is loosely coupled. You don't couple with your email services, right? So your invoice submission service, yes, it need to send the email, it need to send the SMS, it need to have the database, right? But you can scale your invoice services your own without worrying about others. That's the one principle, right? Independently deployable, independently scalable. So how this works, maybe 1000 submission comes, doesn't matter, they will invoke that task, the task will come up, do the job and die its own, right? So one task will only get one invoice, because whatever the parameter comes in, it take that and execute. Sounds good, right? So in the next video, we'll see the full picture of this, how we can invoke this from a remote service and you create something with like a RabbitMQ or something, right? So let's do some useful thing, realistic thing in next video. This video I wanted to show you how and what the task does. So then thank you for being with me, and subscribe this channel because there are a lot more to come, and also share this content with the audience you have. Till I come next time, thank you and stay safe.